All right. Testing, testing. Yes. Making sure I got some sound. All right, I'm back. I believe I forgot to record. I thought I was recording the solution. Earlier I started working on this problem and I didn't get it solved. And I took a break. Then I came back and I actually solved it. I'm just gonna read through it real quick. It says you like building blocks. You especially like building blocks that are squares, and what you even like more is to arrange them into a square of square building blocks. However, sometimes you can't arrange them into a square. Instead, well, first of all, let me go back. If you don't know what this is a kata or kata in codewars.com where you could solve coding problems and things like that. And I'm using the language Java, so I have to solve this problem using the Java syntax. Okay, now, however, sometimes you can arrange them into a square. Instead, you end up with any ordinary rectangle. This, oh, those blasted things. If you just had a way to know whether you're currently working in vain, wait, that's it. You just have to check if your number of building blocks is a perfect square. Given an integral number, determine if it's a square number. In mathematics, a square number, blah blah blah. I know you should know what a square number. If you don't know what a square number is, it is a number that has a product of itself. Okay, for an example, 25 is a perfect square. Why? Because 5 times 5 equals 25. The number 8 is not a perfect square because actually it is a perfect cube though. 2 because 2 times 2 times 2 is 8. But I'm not gonna get into that. But perfect square 4 is a perfect square because 2 times 2 is 4. What else? 4 times 4 is 16. So 16 is a perfect square. 7 times 7 is 49. So 49 is a perfect square. Okay. But the thing is, we are going to be given rectangles. So how do we find this? How do we return a whether or not it's true or false? How do we check if it's a perfect square? So we already know we're probably going to need an if statement. I solved this before, so I'm gonna just go ahead and say first we need to first what we're gonna do is we're gonna take the number and we're gonna find the square root of that number, right? So we're gonna say double. Oops. Matter of fact, we're just gonna say because remember I didn't have to use double. We're gonna say how did I do that? Is equal to, we're gonna assign that to dot math dot square root of n, right? So we initiate that variable square, and then oops, why did I skip do a space? Then we're just gonna come down and we're gonna return. This is what we're gonna do. We're gonna say the square root minus math. Hold on, first of all, we need parentheses. We're gonna say the square root. Ooh, shoot, got something on my finger. We're gonna say the square root. Oops. Square root minus another method called floor. The floor method. What this does is it what it's gonna do is it's going to take, let's say a number is 5.2. It's gonna take that number and round it to 5. Right? It's gonna do that. Round it to the nearest integer. Okay, so we're gonna floor. What are we gonna floor? Well, we're gonna floor in the number, the actual number in. Oops. What am I doing? Yeah, we're gonna floor in. So we're gonna take the difference between the floor and n, and if there, and we're gonna set that equal to 0. Now, if this statement is true, it's gonna return true. If this statement is false, it's gonna return false. Okay? So in other words, if I put 25 in here, right? We're gonna get the square root of 25, which is 5, right? Then we're gonna say 5 minus the math.floor number, and it should equal 0, right? It's gonna equal 0 because 25 is a perfect square. But if it's 26, right? We say 26. This number right here is going to be like 5 point something, and 5 point something minus 5 is going to give us a number that's going to actually be greater than 0, and that will make the statement false. So this is the answer. We're going to test this. Oh, I did something wrong. It says should work for some examples. Something I didn't do right. I think I need to isolate this with this. I don't think I did the parentheses right. I think I got too many parentheses. I think I can get rid of some of them parentheses. Something's right. It says 4 is square number. 2 times 2 expected true, but was false. You know what? I think I did something wrong. I think this is supposed to be this. Test it. Yeah, I put the number. It's supposed to be this. My bad. Yeah, the number, that's like me saying 5 point something minus 26, right? That's gonna, or let's say this is 25. 5 minus 20 is always gonna be false, right? But yeah, now that's right. I corrected it. I made a careless mistake. Okay, so it says you have passed all of the tests. So now I'm going to attempt to submit. And then it says, good job. You may take your time to refactor, comment your solutions. Submit when ready. So I'm going to go ahead and delete these parentheses because it's not there. You don't need those. I don't even think I need those, but go ahead. Yeah. So we're going to go ahead and submit that. And we're done. Just that simple. That was one kata. I just wanted to straighten that up, and because I noticed the video didn't pop up. I don't think I was recording it, but now I got it recorded, and so yeah, that is it. That's pretty much how it is. Why is it bright? Yeah. So, yep. So I'm gonna be doing this every day, for Java, I'm gonna experiment with some other languages like PHP and JavaScript, so forth and so forth. But I'm just gonna be working on Java because I gotta brush up on my Java because I'm gonna start Android project pretty soon. So yeah, and of course you can follow me on that as well. So that's it. I'm going to end this video.